Good afternoon, Ashwin, Parvati. Good afternoon, Alka. So let the others join. In the last class, we were discussing about the Cartesian equation and vector equation of a plane when a normal unit vector from the origin and the perpendicular distance from the origin to the plane is given to us. And also we learned how to find the foot of the perpendicular drawn from the origin. Today, let us start to find the equation of a plane perpendicular to a given vector, and passing through a given point. Plane perpendicular to a given vector and passing through a given point. See the difference. The first type is the plane perpendicular to a given normal vector from the origin. This is not from the origin, a vector which is perpendicular to the plane. It can be any vector which is perpendicular to the plane and passing through a given point. In the first type, the distance from the origin is also given to us. Okay, see. If the plane passes through a given point, say A x1 y1 z1 with position vector A equals x1i plus y1j plus z1k. If the plane passes through a given point A, x1, y1, z1 with position vector A is equal to x1i plus y1j plus z1k, and let vector n is equal to ai plus bj plus ck. Be a vector perpendicular to the plane. See, this is what given to us. A point A, x1, y1, z1 is given. You know that if a point A is given to the coordinates of a point is given to us, then we know how to write the position vector. It is x1i plus y1j plus z1k, and let a vector n. See, in the first type we are using small letter n, and it is the unit norm n cap we are using there. It is a unit normal vector from the origin. That is the difference. Here it is not from the origin. Any vector perpendicular to the plane we are using here. So n equals AI plus BJ plus CK. This is a normal vector, that is perpendicular vector to the plane. Then the vector equation of the plane is given by, the vector equation of the plane is R minus vector A dot vector n is equal to 0. R minus vector A dot n is equal to 0, where R is the position vector of any arbitrary point on the plane. Vector R is the position vector of an arbitrary point in the plane. So the vector equation is given by R minus A dot vector n is equal to 0. And the corresponding Cartesian equation is, see, vector R is the position vector of an arbitrary point. So you can write it as xi plus yj plus zk, and R minus A means it is x minus x1i plus y minus y1j plus z minus z1k, as vector A is given as x1i plus y1j plus z1k. So R minus A is given by x minus x1i plus y minus y1j plus z minus z1k. When we take the dot product of this, we will get this as A into x minus x1 plus B into y minus y1 plus C into z minus z1 equal to 0. So this is the Cartesian equation. Make a note of this. Is it clear? Okay, when a normal vector to the plane and a point A is given to us, the vector equation is R minus A dot n is equal to 0, and its Cartesian equation is A into x minus x1 plus B into y minus y1 plus C into z minus z1 equal to 0. So let us do some problems. Find the vector and Cartesian equation of the planes. Find the vector and Cartesian equation of the planes that passes through the point that passes through the point 1 0 minus 2 and the normal vector to the plane and the normal vector to the plane is I plus j minus k. I plus j minus k. So here the point is given as 1, 0, minus 2. That is x1 by 1. z1 is given as 1, 0, minus 2. Normal vector is vector n, which is given as normal vector is given as I plus j minus k. So the vector equation we can write as vector equation is vector r minus a. A means the position vector of the given point. So it is I plus 0j minus 2k. 0j minus 2k r minus vector a dot. Okay, here we can write vector a I plus 0j minus 2k. This is equal to dot n is I plus j minus k. This is equal to 0. This is the vector equation. Only to substitute the position vector of the given point and to write the normal vector. R minus a dot n is equal to 0. Then the Cartesian equation is Cartesian equation can be written as, see, this is the scalar components of the normal vector is to be taken as a, b and c. This is to be taken as a, b and c. So it is 1, 1 minus 1. And here x minus x1, y minus y1, z minus z1. So we can write it as 1 into a into x minus x1 is 1 plus b. B is the scalar component of this and it is 1 into y minus y1, which is y minus 0, plus c is minus 1 into z minus 2 equal to 0. So we can simplify this, x minus 1 plus y minus z minus 2 equal to 0, or you can write this as x plus y minus z minus 3 equal to 0, which is the Cartesian equation of the plane. Is it clear? The scalar components of the normal vector is to be taken as a, b and c. It is the direction ratio of the plane. So it is a into x minus x1 is 1 here, then plus b into b is 1 into y minus y1 is 0, plus c is minus 1, z plus 2 is equal to 0. Now the second question, it's B part. Passes through the point 146. Passes through the point 146 and normal vector to the plane is normal vector to the plane is I minus 2j plus k. Normal vector to the plane is I minus 2j plus k. Passes through the point 1, 4, 6 and normal vector to the plane is I minus 2j plus k. So the vector equation is vector r minus, write the position vector of this point, it is I plus 4j minus plus 6k dot I minus 2j plus k, which is the normal vector. This is equal to 0. R minus a dot n is equal to 0. This is the vector form. And now write the Cartesian form and give your answer. Write the Cartesian equation and give your answer. You can write it from this itself. Here this scalar components are to be taken as A, B and C. It is 1 scalar component here is 1 into x minus, here it is 1. The point is given as 1, 4, 6. So x minus 1, then minus 2 is the direction ratio here, 1 minus 2, 1. So minus 2 into y minus 4, then plus 1 into z minus 6 equal to 0. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Simplify this. X minus 2y plus z minus 1 plus 1 is equal to 0. Okay. So I hope this is clear to you. If a point and a normal to the plane is given, how to write the equation of a plane. Okay, let us move to the next heading, next type. Plane passing through three non-collinear points. Plane passing through three non-collinear points. Let A x1 y1 z1, B x2 y2 z2, and C x3, y3, z3 be three non-collinear points. Be three non-collinear points, then you know that the position vector of the point A can be written as vector A is equal to x1I plus y1j plus z1k. Position vector of the point B can be written as vector B is equal to x2I plus y2j plus z2k. Then the position vector of C can be written as vector C is equal to x3I plus y3j plus z3k. So three non-collinear points are given to us. And the corresponding position vectors are here. Let R be the position vector of an arbitrary point lying on the plane. That is xi plus yj plus zk. Then the vector equation of the plane is given by is R minus A dot B minus A cross C minus A equal to 0. Okay, the vector equation, see R minus vector A dot B minus A cross C minus A is equal to 0. We have to take care that the same vector is to be taken in all these three cases. R minus vector A dot, here we are considering vector A, so it is B minus vector A cross C minus vector A. You have to consider as the cross product to find the cross product of these two vectors. This is equal to 0. This is the vector equation. Just to substitute the values for these vectors. No simplification needed here. R minus vector A dot B minus A cross C minus A is equal to 0. And you know that the cross product of two vectors is the value of the determinant I, j, k and the scalar components of this. When you take the dot product, we can write it as the Cartesian equation is determinant. It is a determinant. See, the first row is R minus A. That means x minus x1, y minus y1, z minus z1. The first row is the scalar component of the vector R minus A. Then the second row of this determinant is B minus A. That means x2 minus x1, y2 minus y1, z2 minus z1. x2 minus x1, y2 minus y1, z2 minus z1. And the third row of this determinant is C minus A, which gives x3 minus x1, y3 minus y1 and z3 minus z1 equal to 0. This is the Cartesian equation. Here is an order. You have to remember that x minus x1, y minus y1, z minus z1, where x, y and z are the coordinates of an arbitrary point. x1, y1, z1, x2, y2, z2 and x3, y3, z3 are given to us. So this is equal to 0. this clear? Okay. First of all, you have to find whether the 3 points are non-collinear. How can you check whether the points are non-collinear? How to check whether the 3 points are non-collinear? Find the direction ratios of AB and BC. To get AB and BC, it is x2 minus x1, y2 minus y1, z2 minus z1 gives the direction ratios of AB. Then BC, direction ratios of BC is x3 minus x2, y3 minus y2, z3 minus z2. So when you find AB and direction ratios of AB and BC, if they are proportional, then the points are collinear points. Okay, if these AB direction ratios of AB and BC are proportional, then they are collinear points. So if the points are collinear, there are infinitely many planes passing through the points. Collinear means all the 3 points are lying on a line. If these 3 points are collinear points, they lie on the same line. Okay, so if a line is given to us, infinitely many planes can pass through that line. So we cannot write the equation of a unique plane there. So first of all, you have to check whether the given points are collinear or non-collinear. Let us do one question. Find the equation of planes. That passes through one minus 1, 6, 4 minus 5, minus 4 minus 2, 3. One minus 1, 6, 4 minus 5, minus 4 minus 2, 3. So first you have to check whether these points are collinear or not. Let us write this as point A, this as B, and this as C. 3 points are given to us. So first direction ratios of AB. First write the direction ratios of AB. To write the direction ratios, it is 6 minus 1, 5. 4 minus 1, it is 3. Then minus 5 minus 1, it is minus 4. And now you can find the direction ratios of BC. Direction ratios of BC. Minus 4 minus 6, which is minus 10. Minus 2 minus 4, this is minus 6. 3 minus 5, which is equal to 8. See, now all these direction ratios are proportional. 5 by minus 10 is equal to 3 by minus 6 equals minus 4 by 8. They are proportional. Therefore, A, B and C are collinear. So if the points are collinear, infinitely many planes pass through the points. We cannot determine a unique plane. Okay, infinitely many planes pass through the points. Is it clear? Okay, now try another question. 110, then 121, then minus 2, 2, minus 1. Minus 2, 2, minus 1. Check whether these points are collinear or non-collinear. What about these points? Are they collinear? Just find out the difference here. See, 1 minus 1, 0, 2 minus 1, 1, 1 minus 0, it is 1. So the direction ratio 0, 1 and 1. Then find out the difference here. Minus 2 minus 1, which is minus 3. 2 minus 2, it is 0. Minus 1 minus 1, it is minus 2. Are they proportional? Give your answer. Okay, these are direction ratios are not proportional. So the points are non-collinear points. So we can write the equation of a plane. Points are non-collinear. Therefore, we can write the equation of the plane and the vector equation. First, we can write the vector equation. Vector equation is vector r minus vector a is I plus j. Since the scalar component here is 0, we can write I plus j only. So r minus a dot. Now b minus a. B minus a means the scalar components we have to subtract here, and it is given in this. It is I j plus k. 0, 1 and 1. That is 1 minus 1 here, 2 minus 1, 1 minus 0. Okay, 0, 1 and 1, that is j plus k cross second one we have to subtract these two. That you have to take care. We are subtracting the point, first point from R. So we have to subtract A from the remaining vectors. So it is minus 2 minus 1, which is minus 3, 3i. Then 2 minus 1, which is plus j. Then minus 1 minus 0, which is minus k, equal to 0. This is the vector equation. R minus vector A dot B minus vector A cross C minus vector A is equal to 0. Now the Cartesian equation is determinant x minus x1 is 1, y minus 1, z minus 0, then 1 minus 1, 2 minus 1, then it is 1 minus 0. x2 minus x1, y2 minus y1, z2 minus z1. And then the third row is minus 2 minus 1, then 2 minus 1, then it is minus 1 minus 0. This is equal to 0. This gives the Cartesian equation. So you can simplify this determinant x minus 1, y minus 1 is z, 1 minus 1 is 0, 2 minus 1 is 1, here it is 1, then minus 3, 1, minus 1 equal to 0. Find the value of the determinant. X minus 1 into, expand the determinant, minus 1 minus 1, which is minus 2, minus y minus 1 into, this gives 0, minus minus 3, it becomes 3, plus z into 0 plus 3 equal to 0. X minus 1 into minus 1 minus 1, which is minus 2, minus y minus 1 into, and now this is equal to minus 2x, then minus 3y, plus here z into 0, it becomes 0, then plus 2 plus 3, 5, equal to 0. Or you can write this as 2x plus 3y minus 3z minus 5 equal to 0. Is it clear? Okay, now the next is intercept form of the equation of a plane. Intercept form of equation of a plane. So remember, the first one is r dot n cap is equal to d, where n cap is the unit normal vector from the origin and d is the perpendicular distance from the origin. So since this is the unit vector, we can write this as L, M, N are the direction cosines. So Lx plus My plus Nz is equal to D. This is the Cartesian and vector equation of the plane in the first type. In the second type, it is r minus a dot n is equal to 0. Dot vector n is equal to 0, which can be written as a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. This is the second type. And the third one is r minus a dot b minus a cross c minus a equal to 0, or the determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. That is the third type. Now the fourth is intercept form of equation of a plane. Intercept means the point at which the plane intersect the x-axis, y-axis and z-axis. So let A, B and C be the intercepts on the x-axis, on the x, y and z-axis respectively. A, B and C be the intercepts on the x, y and z axis respectively. That means the plane intersect the x axis at the point A 0, 0 and intersect the y axis at 0, B 0 and intersect the z axis at 0, 0, C. Okay, the plane intersect the x-axis at A0, 0. So the x-intercept is A. Intersecting the y-axis at 0, B, 0. So the y-intercept is B. Intersecting the z-axis at 0, 0, C. That means the z-intercept is C. Then the equation of the plane is x by a plus y by b plus z by c is equal to 1. So this is the equation of the plane in intercept form. Equation of the plane is x by a plus y by b plus z by c is equal to 1. So write a question. Find the equation of the plane. Find the equation of the plane with intercepts two, 3 and 4 on the x, y and z axis respectively. X, y and z axis respectively. So we can write it directly: x by 2 plus y by 3 plus z by 4 is equal to 1, or common multiple of this gives 12. So we can write this as 6x plus, multiplying with 12, plus 4y plus 3z is equal to 12. So we can write the equation of the plane as 6x plus 4y plus 3z is equal to 12. So the standard form is x by a plus y by b plus z by c is equal to 1. When you write it in this form, the denominator, that is 2, 3 and 4, gives the x, y and z intercepts. Is it clear? Okay, let us try another one. Find the intercepts cut off by the plane 2x plus y minus z is equal to 5. 2x plus y minus z is equal to 5. So if you want to find the intercepts, you have to write this equation in the form x by a plus y by b plus z by c is equal to 1. So we have to divide the whole equation by 5. Okay, to get the right side as 1, we have to divide the equation by 5. So you can write this as 2x by 5 plus y by 5 plus, minus z by 5 is equal to 1. Dividing the whole equation by 1. We have to write this as x by a, that is x divided by 5 by 2 plus, this is already of the form y by b plus z by minus 5 is equal to 1. Now the intercepts are 5 by 2, 5 and minus 5. So when an equation is given like this, change it into the standard form x by a plus y by b plus z by c is equal to 1. Then the denominators give the intercepts, corresponding intercepts. Okay, another one. Find the equation of the plane with intercept 3 on the y-axis and parallel to ZOX plane. Find the equation of the plane with intercept 3 on the y-axis and parallel to ZOX plane. Can you give the equation? What are the x and z intercepts here? What are the x intercept and z intercept? See, since this is parallel to ZOX plane, it does not intersect the x-axis or z-axis. Okay, it is parallel to the ZOX plane. That means the plane is not intersecting the x-axis or the z-axis. So only to write this as y by 3 is equal to 1. Or the equation of the plane is y is equal to 3. Is it clear? Now the next topic is the condition for perpendicularity or parallelism. Two planes to be perpendicular or two planes to be parallel is the same as in the case of vectors. Okay, in the case of vectors, we are considering a1, a2 plus b1, b2 plus c1, c2 is equal to 0. If this is equal to 0, then the lines are perpendicular, and if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the lines are parallel. The same condition we are using here in case of planes. Only difference is in notations. We are using capital letters there. Okay, write one question. Determine whether the given planes are perpendicular or parallel, perpendicular or parallel. So the first one, 7x plus 5y plus 6z plus 30 equal to 0. 7x plus 5y plus 6z plus 30 equal to 0. And the second plane is 3x minus y minus 10z plus 4 equal to 0. So here the direction ratios of this plane is to be taken as 7, 5, 6. So that is to be taken as A1, B1, then C1. And the direction ratios of this plane is to be given as 3, minus 1, minus 10. This is to be taken as A2, B2, C2. You have to find A1, A2 plus B1, B2 plus C1, C2. If it is equal to 0, the planes are perpendicular. If they are proportional, A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then they are parallel. Try to find out. A1, A2 plus B1, B2 plus C1, C2 equals 7 3s 21 minus 5 minus 60 not equal to 0. Isn't it? So not perpendicular. Are they parallel? No. So A1 by A2 is from the first one itself. A1 by A2 is not equal to B1 by B2. So they are not parallel. Try one more question. Two x plus y plus 3z equal to 0 and x minus 2y plus 5 equal to 0. What about this? Are they perpendicular? So okay, you will get A1 A2 A1 A2 plus B1 B2 plus C1 C2 equals 2 into 1 2, then minus 2 plus 0, 3 into 0, which is equal to 0. Here it is 0 is set. So 3 into 0, it is 0. 2 minus 2 becomes 0. So A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Therefore, the planes are perpendicular. Try one more question. Two x minus y plus 3z minus 1 equal to 0 and 2x minus y plus 3z plus 3 equal to 0. What about these planes? See, when you find this A1, A2, it is 4 plus 1, 5 plus 9. It is not equal to 0, so the planes are not perpendicular. You can find A1 by A2. A1 by A2 means it is 2 by 2. A1 by A2 equals B1 by B2 is equal to C1 by C2. Implies the planes are parallel. So these are the conditions for two planes to be perpendicular or two planes to be parallel. Now the next heading is distance of a point from a plane. Of a point from a plane. Distance of a point from a plane. Let P x1, y1, z1 be the given point and ax plus by plus cz equal to d be the equation of the plane. Be the equation of the plane. Then the distance of the point P from the plane is given by modulus of ax1 plus by1 plus cz1 minus d divided by root of a square plus b square plus c square. This the point is given as x1, y1, z1 and the equation of the plane is ax plus by plus ez is equal to d. So the distance is given by modulus of ax1 plus by1 plus cz1 minus d divided by root of a square plus b square plus c square. When the equation of the plane is given in Cartesian form. Here it is given in Cartesian form. Then you have to write this as ax plus by plus cz minus d equal to 0. Substitute xy and z by x1, y1, z1, the given points. Then divided by root of a square plus b square plus c square gives the distance of the point from the plane. Let us do one question. Find the distance of zero, 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 that is the origin, from the plane 3x plus 4y plus 12 equal to 0. 3x plus 4y plus 12 equal to 0. So the distance is equal to ax plus by plus cz is 0 here, plus d equal to 0. This d is transposed here, plus 12 is equal to 0. Find out the distance. Replacing x, y and z with 0, 0, 0. So it is 3 into 0 plus 4 into 0 plus 0 into 0 plus 12 divided by root of 3 square plus 4 square, that is 9 plus 16, which is 5. So the modulus is 12 by 5. Is it clear? Okay, one more question. Find the distance of the point (3 minus 2, 1) from 2x minus y plus 2z plus 3 equal to 0. Find the distance of the point 3 minus 2 1 from 2x minus y plus 2z plus 3 equal to 0. What's the distance? Chaitanya, once again check it. What about others? So okay, we can write this as modulus 2 into 3 minus 2, then plus 2 into 1, then plus 3 divided by root of 2 square plus 1 square plus 2 square. So this is equal to 6 plus 2 8 plus 2 10 plus 3 13 by 3, right? So this will conclude today's class. Try the remaining questions of question number 13 and 14, exercise 11.3. Okay, 11.3, question number 13 and 14. Try the remaining questions and we will continue the class, remaining topics in the next class. Thank you.